Hello, in this video we are going to start our first chapter, that is water demand. So, chapter 1, water demand. First of all, we should know what is water demand. Water demand implies water quantity estimation. This is water quantity estimation, and this is the quantity that is required for municipal use. It requires two data. First is forecasted population. Second is rate of consumption. Forecasted population unit is N, and this is liter per capita or liter per capita, liter per capita per day. So this is capita. Capita means population. So this water estimation that we do is not for current period. This is for future period, because the components that we are going to design in municipal supply are to be designed for future period. If we design it for current period, then it will be obsolete in some near future. So what is this design period? The quantity of water is worked out with provision of requirement of future population, because the components are very costly. The structure is very complex, like dams, reservoir, say, and other distribution network. This is very costly. Hence, we have to design keeping in mind of future period. Now, this period must be designed optimally. This period must be designed optimally. It should neither be too high, neither be too less, because if it's going to be too high, then our dams, our reservoir is going to be very complex, and we are going to spend a lot of money, which we should not. So there are four methods of population forecasting. Methods of population forecasting. First method is arithmetic increase method. Second is geometric increase method. Third is incremental increase method. Fourth is decreasing rate of growth method. They have some other names also, which I'll be describing now. So let's discuss the first method, that is arithmetic increase method. This is based on assumption that population increases at constant rate from last population. The average increase in population is considered to compute the future population. It is used in cities which are sufficiently large and are already established. So, like year population, say in 1981 we have population P1, 1991 we have population P2, 2001 we have population P3. So we have to calculate population in 2011. So how we will do it? We will calculate increase in population. Since it is arithmetic, so we will calculate the arithmetic difference. So say this will be P2 minus P1, that is equal to x1. Next is P3 minus P2, this is equal to x2. So this is P4. How we will calculate P4? For calculating P4, we have to calculate like this P4 minus P3. Now we are not calculating, but I will be telling you this thing. Say we have to calculate any nth time population. So this is P naught is the last known population. So we will calculate this x bar, that is average increase per decade. This is equal to x1 plus x2 plus x3 divided by 3. In general, it is going to be x1 plus x2 plus so on plus xn divided by n. So now let's say P 2021 we have to calculate. So last known population plus x bar. This is P4 plus x bar. P 2031 P 2021 plus x bar. This is equal to P4 plus x bar plus x bar. So like this, the general formula is going to be Pn is equal to P naught plus nx bar, as it is P4 plus 2x bar. So this is going to be the general formula, general expression. Pn is equal to population after n decades from last known population. So what is important in this? It is important the last known population, because this formula is used in last known population only. This P naught is last known population. This is last known population. So this was our first method. Now we are coming to the second method. This is geometric increase method. Other name for this is uniform rate of growth method. Many times in exam like GATE, they may ask uniform rate of increase method. Uniform rate of, sorry, this is increase. So geometric increase method or uniform rate of increase method. So geometric is equal to uniform rate. This is to get an idea. So in this method, percentage growth rate from given data is found out. In this method, percentage growth rate from given data is found out. The percentage growth rate is assumed to be denoted by R. This R is compounded over existing population and is calculated from past known data. R is computed by geometric mean. This R is computed by geometric mean, and this is applicable for young and rapidly developing cities. Applicable for young and rapidly developing cities. So in this geometric increase method, you have to remember that this is applicable on young and rapidly developing cities, while arithmetic increase method is applicable on sufficiently large and already established cities. So we are going to do an example to illustrate how this method is used. So year population and say 1981 we have population P1, 1991 we have population P2, 2001 we have population P3, 2011 we have population P4. So we have to calculate increase population. So increase in P2 minus P1 is equal to x1, P3 minus P2 equals to x2, P4 minus P3 equals to x3. So percentage increase in population, because in this method percentage growth rate from given data is found out. So what is percentage growth rate? This is percentage growth rate, like P2 minus P1 divided by P1 into 100. This rate is R1. So just like same, P3 minus P2 divided by P2 into 100. This is R2. P4 minus P3 divided by P3 into 100. This is R3. Here P naught is last known population, like this is P naught. P naught is last known population. So I am writing a general expression for percentage increase in population is equal to increase in population divided by original population into 100. So there are going to be multiple values of r1, r2, r3, so on up to rn, where rn is calculated for last known population. So how do we get an average? How do we get a mean? So from Government of India method, Government of India manual, R is computed by two ways. First is geometric mean. This is preferred. Whenever there is a question in exam, you have to use geometric mean. This R is equal to R1, R2, R3 up to Rn, multiply all, divided raised to power 1 by n. Second is arithmetic mean. This is not preferred, but if there is demand in the question that you have to calculate this percentage increase by arithmetic mean, then you have to do like this: R1 plus R2 plus R3 plus so on up to Rn divided by m. So usually you have to prefer this geometric mean in the method geometric increase method or uniform rate of increase method. So what is the general expression for calculating pnth population? Is Pn is equal to P naught 1 plus R by 100 raised to power n. This is general expression. And I am writing it again, that geometric increase method, or the other name is uniform rate of increase method. Increase method is applicable on young and rapidly developing cities. Now comes the third method. Third method is incremental increase method, or method of varying increment. Method of varying increment, both are same. In this method, increment over increase y is found out, and population after n decades is found out. So increment over the increase y is found out. What is this y? This y is this. This is y. Oh, sorry. This is not increment. This is x. I'm sorry. This is x. Increment. I'm going to copy this data so that you know what is this thing. So let's copy this data. Paste it. So increment over increase. Here we are calculating increment over increase, that is y. So y is calculated here, x2 minus x1, this is y1, x3 minus x2, this is y2, just like this. So I'll be giving an example for you so that you can understand. Say this is population 2, 4, 7, 9, 13, 19. This is population. So what will be x? 4 minus 2, 2. 7 minus 4, 3. 9 minus 7, 2. 13 minus 9, 4. 19 minus 3, 6. So what is going to be y? 3 minus 2, 1. 2 minus 3, minus 1. 4 minus 2, 1. 6 minus 4, 2. So this is x bar will calculate, and from here y bar we are going to calculate. Y x bar is going to be equal to 2 plus 3 plus 2 plus 4 plus 6 divided by 5. Y bar will be equal to 1 plus minus 1 plus 1 plus 2 divided by 4. This is equal to 0.75. So in this, P1 will be equal to P naught, that is last known population, plus x bar plus 1 y bar. P2 will be equal to P1 plus x bar plus 2 times of y bar. Similarly, P3 will be equal to P2 plus x bar plus 3y bar. So the general expression is going to be Pn is equal to P naught plus nx bar plus n plus 1 divided by 2 y bar. Because if you expand it, it will look like this: P naught plus 2x bar plus 3y bar. So the general expression is going to be this general expression. And for Indian conditions, arithmetic increase method gives minimum value, incremental increase method gives medium value, and geometric increase method gives largest value. Practically, y bar is usually greater than 0 for Indian conditions. So I'm going to revise you the names. First is arithmetic increase. Second is geometric increase or uniform rate of increase method. Third is incremental increase method or method of varying increment. Now comes the fourth method. Fourth method is decreasing rate of growth method. So for this we are going to give a direct example, or let's copy the same data, paste. Okay, so we are going to calculate percentage R, which will be calculated by P2 minus P1 divided by P1 into 100. This is percentage rate of growth, just like we calculated in geometric increase method. So like this, P3 minus P2 divided by P2 into 100. So P4 minus P3 divided by P3 into 100. Now decrease, percentage decrease in value of r. So let me write it somewhat here. This comes here and this comes, say it here. Okay, this will be blank, this will be blank, this will be blank, and this will also be blank because we have to calculate the difference. So difference will be between these two. So this value is going to be r2 minus r1. This value is going to be r3 minus r2. So this, say delta r1 delta r2. So we have to calculate this average, which is going to be equal to delta r1 plus delta r2 divided by 2. Okay, like this we have to calculate. Say we are going to do it with an example. So I'm going to write here population. Say population is of 2007, or okay, 2007 population is 50, 2017 population is 55, 2027 population is 70, and 2037 population is 95. So what is going to be population is 2000, population in 2097, let's say. What will be population? For this we have to calculate first r percentage. It will be calculated like this: 55 minus 50 divided by 50 into 100, 70 minus 55 divided by 55 into 100, 95 divided by 70 divided by 70 into 100. So I'm calculating with the help of calculator now. And this is 10, this is 27.27, this is 35.71. So delta r, this is 27.27 minus 10, this is 17.27, 35.71 minus 27.27, this is equal to 35.71 minus 7.27, 8.44. So delta r average is equal to 12.855. Okay, actually this is going to be a very large solution, so we will just calculate 2057. So first we have to go to population in 2047, which will be equal to P plus R minus delta R average divided by 100 into population, last known population, that is population 2037. So this is equal to 95 plus the value of r is 35.71, but the next r will be this divided by 100 into 95, which will be equal to 106.71. So population in 2057 will be equal to, last known population is 116.71 plus this increase is, this decrease is noted. What is going to be this decrease? This is equal to 22.855. So 22.855 minus 12.855 divided by 100 into last known population is this. So after calculating we get this value 128.381. Similarly, if you have to calculate population in 2067, last known population is this, plus we have to calculate this. This is 10. So 10 divided by, or 10 minus 12.855. So now this value will come in negative into 128.381. So now this population will decrease. Because this is going to be negative. This value is going to come 124.715. So like this we calculate decreasing rate of growth method. This method is applicable only when rate of growth population shows a downward trend. So what is the applicability? Write applicability here. Applicable on cities only when rate of growth of population shows downward trend. Now our next topic is population forecasting. There are three methods of population forecasting. First is simple graphical method. Second is comparative graphical method. Third is logistic growth curve method. So we are discussing simple graphical method. This provides very approximate result and its use is very limited. Long duration record must be available. So this, like we have to have this record available in order to forecast this population. Unknown, known. So long duration, this is long duration record already available. then only we can forecast this unknown population. Forecast, this is using simple graphical method. It cannot analyze changes in population trend in future. So might be there may be a spike, there may be some like growth or maybe downward spiral, but this will keep on increasing because we are following a particular trend. So this is simple graphical method. So let's discuss the second method. Second method is comparative graphical method. So cities with similar initial population growth are selected. Cities with similar population growth are selected. Second is, and those have which have shown similar manner as concerned city X, and their graphs are plotted and superimposed on each other. So when we superimpose, say this is the mean which we get, and this is used for forecasting the population of city X. City X. So we get this growth rate from those cities. So we superimpose this graph and say population, last known population is P naught and initial population may be Pi of city X. So this rate of increase, or say this shape, is superimposed on this particular graph to get the value of next known population. So their graph are already available, so we draw a median. This shape is used to forecast the city X population in future. This is comparative graphical method. Now coming to the third method. Third is logistic curve method. Logistic curve method, also known as growth curve method. The three important factors responsible for population change are birth, deaths, and migration. Birth, death, migration. The hypothesis is when these factors do not produce extraordinary changes, the population follows growth curve characteristic of living things within limited space and limited economic opportunities. So if they don't change much, then a population follows a general growth curve characteristics. Say this is limited area, and if there are no major big changes in birth, deaths, and migration, and these have limited resources, then population will saturate at some point. Initially it will grow at a logarithmic rate, then it will stagnate, and then it will continue to reach a constant value. So this is low growth. This is linear, and this is double derivation p divided by dt square is less than 0. In this is equal to 0, and in this is greater than 0. So as per P.F. Verhulst, logistic curve equation can be written as ln ps minus p divided by p minus ln ps minus P naught divided by P naught equals to minus K PST. We are writing all P as capital, which can be also written as P equals to Ps upon 1 plus m e raised to power nt, which is also equal to Ps divided by 1 plus Pm ln inverse nt. E raised to power can also be written as ln inverse nt. Here Ps is saturation population, maximum carrying capacity. This is Ps. Say this is the growth curve. So this is maximum saturation population, and this is given by a formula. Ps is equal to 2 P naught P1 P2 minus P1 square P naught plus P2 divided by P naught P2 minus P1 square. So you can memorize this very easily. P naught P2 P1 square P naught P2 minus P1 square. You have to just mug up this formula. It's very easy. And m is equal to Ps minus P naught divided by P naught. And n is 1 upon T1 ln P naught Ps minus P1 P1 Ps minus P naught. And this T1 time is equal time. So I am plotting a graph like this is T1. Then the next period is also T1 only. At this population is P naught. At this population is P1. At this population is P2. This is equal time period. T1 equals to T2 equals to T naught. Okay. And there are, then comes the type of water demand, which we'll cover in next video.